Lift is generated in an aircraft through the principles of aerodynamics, specifically by creating a pressure difference between the upper and lower surfaces of the wings. When air flows over an aircraft wing, it encounters a curved shape that causes the air to travel at different speeds over the upper and lower surfaces. According to Bernoulli's principle, an increase in the speed of a fluid, in this case, air, results in a decrease in pressure. Therefore, as the air flows faster over the curved upper surface of the wing, it creates lower pressure compared to the relatively slower moving air on the flatter lower surface. This pressure difference between the upper and lower surfaces of the wing creates an upward force known as lift. The lift force acts perpendicular to the relative wind, the airflow direction, and opposes the force of gravity. This enables the aircraft to stay aloft and generate the necessary upward force to counteract its weight. Several factors affect the generation of lift. Wing shape. The shape of the wing, including its curvature, camber, thickness, and wing profile, plays a significant role in lift generation. The curved upper surface, top, and flatter lower surface, bottom, are designed to optimize lift. Angle of attack. The angle at which the wing meets the oncoming airflow, known as the angle of attack, affects lift. By increasing or decreasing the angle of attack, the pilot can adjust the amount of lift being generated. Airfoil design. Airfoils are specifically designed wing shapes that optimize lift and reduce drag. They are engineered to provide efficient airflow over the wing surfaces. Airspeed. The speed of the aircraft affects the amount of lift generated. Generally, higher airspeeds result in increased lift, up to a certain point where the wing may experience flow separation and reduced lift, stall. Wing area. The size of the wing also influences lift generation. Larger wings typically generate more lift due to their increased surface area. It's important to note that lift is not solely responsible for keeping an aircraft in the air. Other forces such as thrust, generated by engines, and control surfaces, ailerons, elevators, and rudder, are involved in maintaining controlled flight. The balance and interaction of these forces allow an aircraft to maneuver and stay airborne.